Well, welcome to this lesson on relations to functions. So in this lesson, we're going to take what we've established about sets and relations and hone that into functions, which are a specific kind of relation. Now, one of the things I wanted to cover at the outset is just a slight change in the way that we write the mapping. So what we did last class was we were mapping using the brackets. And so we might map 1 to 4, and then 2 to 5, and then 3 to 6, like that. And that's fine, and it shows the mapping from one set onto another, but it does get a little jumbled up with the way that the arrows overlap and cross over each other, especially if you're doing them all in the same color. It just becomes very easy to lose track of where they're going. So one of the things that we might do instead is we use this vertical format where we actually use the bubbles to represent the sets and then draw the lines from one bubble to another. And it doesn't eliminate overlapping arrows, but it does help untangle them somewhat. So we could have 1 to 4, 2 to 5, and 3 to 6 like that. And you can see right off that that is much easier to see what is mapping to what. So I wanted to quickly cover that little notational change. It's for practical purposes. It doesn't mean that your arrows will never cross, but it does make it easier to follow where the arrows are going as a rule. Okay. All right, so that brings us to what is a function. Now, usually by the time you get to Algebra 2, you have encountered the word function and the notation for function. My experience has been, though, that students don't always have a good mastery of what it is, and so we're going to try to approach that from the sets framework. A function is a relation. So first of all, a function is a relation, meaning it is a mapping from one set onto the other in which each x value, let me make sure I have my pen activated, yep, maps to only one y value. Okay, and so that it meets that very specific criteria. So for an example, we have the x's over here. Okay, those are my sets of x's, and this is my set of y's, and I could map each of those to the 4, and that would be a function. Here's why it's a function. The definition of a function is that each x maps to only one y. So if I look at the 1 is my x, it only maps to a 4. The 2 only maps to a 4. The 3 only maps to a 4. So each x maps to only one value of y. If you were to do that out as a set of ordered pairs, it would be the 0.14, the 0.24, and the 0.34. So again, keep your eyes on that definition. Each x maps to only one y. Now, in this case, in the non-example, we have a 1 and a 2 in there for our x's, and I might map the 1 to the 4 and the 1 to the 5 and the 2 to the 6. Okay, and this one is not a function because you have an x value, that would be the 1, that maps to 2 different values. Okay, that is not okay. It is okay if more than one x maps to a single y, but it is not okay for a x value to map to more than one y value. If you were to look at these as a set of ordered pairs, it would look something like 1, 4, 1, 5, and 2, 6. All right, so that's what a function is. And I would say in Algebra 2, the importance of something being a function really doesn't take hold. We can define it, we learn how to work with it, we become fluent in the notations. And in future math classes, it becomes very important to know whether or not a particular relation is a function. So each x maps to only one y value. Now, what do functions look like when they are graphed? I think I've got this one going straight across. I don't have my notebook handy because it's in a bag. I could grab it. I'm working off of notes that I did earlier for another project I was working on. So, yep, we're going to work from these. Okay, so in this case, we're going to map them going straight across. So -1 maps to -5. That's supposed to be an error there. 0 maps to -3. I don't know why I doubled the negative. That was probably just like I hit the key, or it didn't type and then it typed late. It's just a -3. 1 to -1 and 2 to 1. Okay, now I will go ahead and write those as ordered pairs. So we have -1 mapping to -5, 0 mapping to -3, 1 mapping to -1, and 2 mapping to 1. So when I come over here to graph them, I have -1, -5, so that's going to be down here. We have 0, -3. All right, 1, -1, and 2, 1. And what I hope you notice with that is that these points are not randomly placed there. That particular mapping looks like a line. Okay, we don't have all the points in between. It's not, but those 4 points are definitely lining up. So when you graph a function, it will behave a certain way. So this is an example one. Now, just as an aside, this type of function is called a 1-to-1 function, and that's because each x goes to only one y and vice versa. So it's that direct, like 1-to-1, and you don't have any doubling up at all. So you're not doubling up on the x's because that would make it not a function, but you're also not doubling up on the y's. You can double up on the y's and it is still a function. This is a special kind of function called 1-to-1 where you're not doubling up on any of them. So that might be a little piece of vocabulary to hold. Now, what about things that are not functions? So this is actually the same set of points. And so I'm going to go ahead and draw the same connections, but this time I'm going to add something that makes it not a function. So it would not be a function if any of those x values mapped to more than one y value. So I'm going to go ahead and make this 2 also map to the -1. Now I have disqualified that from being a function because I have an x value that now maps to more than one y value. So when I come over here to graph it, okay, so we have -1, -5, 0, -3, 1, -1, 2, 1, and then we have 2, -1. And what I want you to notice is what happens with that disqualifying mapping. The mapping that caused it to be disqualified. And I could probably write those. So we're going to write these out again. That's -1, -5, 0, -3, 1, -1, 2, -1, and 2, 1. This is the point that was my disqualifying point. That was the one that I added in. Okay, I was like, I'm going to add in another mapping and I'm going to disqualify it. That would be this point right here. And what I want you to notice, that's the situation that got it disqualified. When you have one x mapping to more than one y, you end up with these vertical stacked points. Okay? Stacked points. So that's what happens when it becomes disqualified. You end up with points that are stacked. So if you're looking at a graph, if you don't see any points that are stacked up, then it's probably a function. If you see even one stacked point, like one location where there's a point stacked over another point, you could kind of draw that vertical line, it is not a function. It has been disqualified. So that brings us to this key idea. If there are any vertically stacked points at all, the relation is not a function. And that's one of the easiest ways to tell whether something is a function. It's not always easy to tell in other formats. Okay, like you got to know what you're looking for, but graphs, very quickly, you kind of look over it. If you see any points stacked over each other, it's not a function. So if you saw something like this, okay, you could say that is a function, because if you look at all the points, there's no point stacked above it. The moment you do this, now it is no longer a function because that point is stacked over that point. Okay, and so the moment you see any stacked points, not a function. And sometimes you'll hear this referred to as the vertical line test. I did not put it in my notes this year as the vertical line test because it's a little awkward to define it, and I think it's better if you see what's happening. It's not a function because it violates the definition, which is X maps to only one Y. Now, some key vocab that we use when we're talking about functions. You've probably heard this before. Algebra 2, this tends to be kind of unpopular vocabulary. People don't like it. But domain and range. The domain is the set of numbers in that starting set. So if you've got your mapping, okay, and you've got your X's and your Y's, and you're starting that mapping and it's going from one set onto the other, this set over here is called the domain. And so you might hear the domain defined as all the X's, like, or all the possible values for X. But again, I'm trying to start this year talking about sets. So the domain is the set of numbers in that starting set. And the range is the set of numbers in the ending set where the mapping terminates. So whatever is in that bubble or whatever is in that set, that is your domain, and vice versa. Now the domain could also be called the X's. I kind of want to associate the word domain with the X's, and you'll also hear it called the inputs to a function. So we'll kind of get to why that's a good way to think about it too. But the inputs, it's like the number that you're starting with. What am I putting in? And the range is also known as your Y's or the outputs. Okay, and so you put something in and then you get something out. And so you have your domain and your range. So let's take a look at an example with the notation. So the pattern here, so we've got this, and I think in my notebook, I think the 10 was an add-in, okay? But this is where it can get a little tricky. So you've got -1, and it maps over to a -6. And then you have a 0, and it maps to a -4. 1 maps to -2, and 10 maps to 16. Now, this is like a little tricky. Like, what's the pattern? How are you getting from a -1 to a -6? What I would probably do, honestly, if I didn't know and have it in front of me, is I would graph it. So we got -1, that's -4, 5, 6. So there's a point down here. 0, -4, 1, -2, and 10, 16, I can't really fit on there, so I'm going to leave it at that. And what I noticed there is that looks like a line. It looks like the y-intercept of that line is -4, and it looks like the slope is up 2 over 1. So using rise over 1, run. It looks like the equation for the line would be y equals 2x minus 4. Okay, if you think about the slope was 2 and the y-intercept was -4. So I think the pattern is this, 2x minus 4. Now I want to check that. Okay, so in other words, to get the y, I would take x, multiply it by 2, and add 4. Let's see if that seems to work. -1 times 2 is -2, and -2 minus 4 is -6. Looks good. Oh, that way. The camera's backwards. 2 times 0 is 2. 2 times 0 is 0. 2 times 0 is 0, and 0 minus 4 is -4. 1 times 2 is 2, and 2 minus 4 is -2, and 10 times 2 is 20. 20 minus 4 is 16. So that pattern works. So what that tells me is that the way the two sets are related is with that pattern 2x minus 4. Now, I use the graph over here to kind of figure it out. You could figure it out other ways. You could just kind of guess and check. You could try different ways to figure it out. Typically, if the pattern is something like just multiplying by a number or just adding a number, you might be able to see it. When you start to do more than one thing, then the pattern becomes harder to see, and other tools are better, like looking at a graph. Now, what this means is, I want you to notice the etc. Essentially, what I'm saying there is pick anything you want. Okay, so I just went -1, 0, 1, at 10, but what about 15? What about 1/2? Like, we could keep going on. We can pick any number on the number line for x, so our domain is all real numbers. And early in Algebra 2, that probably doesn't mean much to you. You're like, why don't we just say all numbers or everything? What's this with real? Are there fake numbers? Sorta, like we don't call them fake numbers. And you probably don't know what they are yet, but they are part of Algebra 2. So, but for now, you can think of any number on the number line. So I can plug in any number I want for x, multiply it by 2, subtract 4, and that will give me the number in the other set. So for example, I could pick, say, the number 2 over here, plunk that down in my domain. Do 2 times 2 is 4, and 4 minus 4 is 0. And there we have it. So we have like another mapping, and we could just keep going. We could pick fractions and decimals and negatives and whatever number you wanted. Pick it if it's on the number line, multiply it by 2, subtract 4, and you could create a new mapping. So this is where we get some of this notation from. So we have y is equal to 2x minus 4, and that's what you're familiar with from Algebra 1. You have like your x's and your y's. Now, what we know is that y is a function of x. What that means is, so I'm reading off the slide right here. Y is a function of x, or you could use the equal instead of the word is. So y equals a function of x. It just means that this particular relationship meets the definition of being a function. Okay, so that's what that verbiage means. The shorthand for is a function of x is that notation right there. It's got the f outside and then the x in the parentheses. And so what you might see instead of y equals 2x minus 4 is you might see f with the little x equals 2x minus 4, and you read that out loud, f of x, which is a shorthand way of saying function of x. So it's saying whatever this is, the output is a function of x, meaning it meets that requirement. Okay, so whatever you see right here is going to meet that requirement of every x maps to only one y. Okay, in the range, and that's how you read it. Okay. And you've probably seen that before. F of x is not actually the same thing as y, because there are equations and relations that are not functions, and those would also have y's in them. So functions are like a subset of that. You can always take an f of x and you can put a y in instead if you don't like it, but you can't go the other way around and just take any old y and put an f of x in its place, because not all of them would be functions. Okay, so what does this notation actually mean? Again, I've heard too many students say, well, f of x is the same as y. No, again, not. It means it's a specific kind of relation called a function. So f is actually the name of the function, okay? Oops, that is not a pen, is it? Let's try again. The name of the function, and it indicates that the relation is a function. So that's what f does. And you can name the functions anything you want. So we usually start with f because function starts with f. But then we might use g, h, those come next in the alphabet. I had a graduate professor who named his functions Bubba. You can name them after yourself, your cat, your dog, your mom. Sometimes I name them after students in class. But the f part is the name, and it indicates, yes, this particular relation is a function. It meets that definition. The x part tells us which number you are pulling from the domain. So remember, you've got your domain and your range, and you've got all these numbers. So maybe you've got a 3. That x value tells you what number you're pulling out of the domain. Okay, it tells you which number is there. And then so this is what it means. So f of -1 equals 6 means that you pulled a -1 from the domain, and it maps over to a 6 in the range. So that's what that notation does. So it tells you, hey, we had a -1 here and a 6 here, and they map to each other. In other words, when x is -1, that's a y, y is 6. Okay, so that's what that notation means. So the thing in the parentheses tells you what am I pulling out of the domain, and then what it's equal to tells you where it went and mapped to in the other set. All right, and so this was intended to just be like a match thing. So you've got the name is this, the input from the domain, okay, and then this is the relationship to find the element from the range. It tells you what do you need to do. So if you were to see f of 3, okay, which is how you would read that, it means, hey, pull a 3 out of the domain. That's the number we're looking for. So we've got all these numbers. We're going to pull a 3, and it's asking you to find what is the element in the range that it maps to. Well, you've got your little equation here. So you're going to take the number from the domain, multiply it by 2, and then subtract 4. So this would be 6 minus 4, or 2. And what that tells you is you're going to map to a 2. So when your x value is a 3, your y value is a 2, and then you could go and plot it, which would in turn lead to a graph. Now, in order to practice this, so this is the practice set, and it looks like my face is covering something important there. So I'll turn my face off. So this is the practice set for numbers 1 and 2, graph the mapping and state whether it's a function. So for these first 2 problems here, grab a coordinate plane, okay, plot the points, okay, whether it's given to you as the arrows or whether it's given to you as a set of ordered pairs, and then answer like, yes, it is a function, or no, it is not. Does this meet the definition of function? For 3, try to find the pattern, okay? And so like -1 maps to 1, 0 maps to 0, 1 maps to 1, and 2 maps to 4. So what's the pattern there? Can you find it? And is that a function? For 4, state the domain and range for number 1. Use the appropriate notation. Domain and range are sets. So make sure that when you are writing sets that you actually open up the set brackets and you're saying this set maybe is my domain. So use a D for the domain and you list what would be in that set. Do the same for the range. For numbers 5 through 8, evaluate the function. The word evaluate usually means plug in the numbers and tell me what is equal to. So you're given the relationship and now you're being told, hey, pull a 1 out of the domain. So pull a 1 from that set on the left and here's your relationship. Go find me the range that goes with it. Find me the other end of the mapping. And again, you can plug positives, negatives, and decimals. Now the last part, I don't actually see the thing where I can turn off my camera. All right, well, evaluate g of x. I believe I remember what this was. It's g of x equals the square root of x for x is equal to 25. Okay, so it's like the same thing, just written another way. It's g of x. I know my g looks like an s. I'm writing with my fingertip on a laptop. Okay, equals the square root of x, and then for x is equal to 25. And question 10 is a circle a function? Yes or no? All right, so that's that. You guys know how to get a hold of me if you have questions, and hopefully I will see you in class or in the next video soon.